Olá, boa tarde. Bem-vindos à última sessão do dia do Cyber and Cloud Expo. Estaremos agora a J Santos, que é o Product Growth Team Lead da J Scrambler, em que o tema será How to Assure Quality in a Security World. A apresentação será em inglês, mas qualquer questão poderão colocar no chat, que no final haverá tempo para perguntas e respostas por parte do Joss. Joss, boa apresentação. Estarei deste lado com a câmera desligada para qualquer ajuda.
Obrigado. So, I'm going to bring you with me on a journey of how we guarantee quality in our world, a security world, the different challenges we've been facing, and how we've attempted to solve them. So, about me, my name is Santos. I've been a QA automation engineer since 2018. I've been at J Scrambler since 2019. In 2020, they've offered me to step up to the challenge of being the QA team lead, as well as the product growth engineering team lead. I'm also a big D&D fan, kind of a nerd, I know, we all are in some way. So what is J Scrambler? And the best way to answer that question is to present what are the J Scrambler offerings. First of all, we have the code integrity product. Code integrity product is a product that obfuscates your JavaScript that is being ran on the customer's website. And then we have the web page integrity. Web integrity is, in the most basic way, the antivirus for your web page. It will allow you to first monitor what's happening on your website. Then you'll be able to decide if that behavior is correct. You'll be able to sandbox and to create rules that will allow you to control what's happening. And if something is happening that you don't want to, being able to act accordingly, either through blocking or through alerting any kind of person you want. So code integrity, as I said, we obfuscate code. We take this perfectly valid and well-written code, and we turn it into something like this. This code is functionally the same to the one on the left-hand side of the screen. But as you can see, through the usage of the JavaScript language polymorphism and features, we're able to transform it into something that is much more resilient. It's a one-way obfuscation. We have no way of undoing the obfuscation on the right side. The obfuscation is a way of deterring any ill intent or malicious behavior from anyone trying to obtain information or higher privileges from the code. The obfuscation is not guaranteed to stop every kind of attempt, but is resilient enough to deter, I would say, 99.9% of the people who are trying to do it. And then we have web page integrity. In web page integrity, we have a perfectly functioning website. And through the usage of our tool, we're able to list everything that's happening on a website, either the execution of some scripts, the modification of your HTML code, the sendage of information through a network request. And from there, we're able to decide if that behavior is working as intended, making sure that we are not vulnerable to any kind of web-based attacks such as customer hijacking, making sure that if I have my WPI product working, my customer is not hijacked. How does that work? Imagine we are Amazon or e-commerce owners. We have a product that's currently offering on our website. Through the usage of extensions, a client of our website might be able to find that exact product somewhere else at a lower price or a different price. And we might have that customer being hijacked from that purchase. Through the web integrity, we're able to prevent that. We're also able to prevent a major attack, which is mage card attacks. Mage card attacks were through the infection of third-party libs. Most of the time, these libs handle payment processes, which are most of the time third-party to a e-commerce or any kind of platform you have or you own, and you offload the responsibility to them. A mage card attack infects that third-party lib and therefore infects your platform. From there on forth, anytime you use or a customer uses that infected third party, is actually being exposed to that attack. A nice example of that attack was the British Airways incident, in which their payment processes were compromised, and over 300,000 customers had their credit card information exfiltrated. They were able to go through the purchase, but the information they used to pay for those services was actually exfiltrated to malicious people. So, how do we maintain quality? I'm here to show you a different story from what you've been mostly hearing yesterday and today, which was an exposition of how products work and how they are tackling these problems. I'm here to show you different kind of problems, which is how do we make sure that our products are working as we intend them to? So the best way to do this is to look at how our products work in a really, at I would say, high level view or scope, and tackle every single interaction we have with different systems. So we have our code integrity overview. We have the Jscrambler stack in the middle, which is able to obfuscate code. Then we have the three different interfaces in which the user is able to access our product. We have firstly the dashboard, in which the user is able to work as uploading their files, obfuscating them, and retrieving their obfuscated code. Then we have our command line, which is mostly used in development pipelines and everything that is internal. And then we have our plugin. Our plugin is mostly used in cases in where our customer has a development framework, which is for JavaScript, which are Angular, React, Vue, Ember, NativeScript, everything that uses JavaScript as its basis, and uses them to deploy their code to their website. And our plugin is trying to seamlessly integrate into that pipeline. Then from our Jscrambler stack, we have the creation or the generation of obfuscated code. And that obfuscated code has some kind of configuration attached to it. That configuration could be the type of transformation we use, which is the different techniques we use to pick up the source code and transform it in protected code, and also the different countermeasures. Along with obfuscating code, we also provide countermeasures. Countermeasures are active measures of deterring the ill usage or the misuse of the protected code, which are domain logs, date logs, operating system logs, which if someone tries to do something that the config or the configuration doesn't allow it, the code might break, you might get a real live notification. We have every kind of follow-up measures to do that. So the best way to make sure that everything works is to make sure that every single unit or every single path works. So let's begin. Our dashboard interface. This is currently our most traditional interface. I believe it's the most used in software development. We have a dashboard, we have an API, we have a backend. It's only we only have internal changes to that. This will be relevant further along this journey, but keep in mind that we only have internal changes. Everything that changes is originated from our teams. Only development teams make those changes. We have API and UI tests, making sure that the UI is working as intended, and making sure that the API, if the customer does a certain request, it has a certain behavior in response. Then we have the CLI. The CLI, again, is only influenced by internal changes. If anything happens in between those two, it mostly originated from our development teams. We have a command-based testing in which we try to test every single command that the customer has available to use. We also do arguments randomization. Each command may or may not use arguments, and different arguments may lead to a different response, and try to make sure that we bring some randomization, a little bit of fuzzying to all of the arguments we're doing, so that the customer always has the expected behavior. And this one, the CLI, is used in the next interface. The next interface is the plugin. As I said before, it's used mostly in framework integrations, and a successful integration is when our customer doesn't know, or at least doesn't, it's not visible to the customer that he's using us. Everything went so seamlessly throughout this development pipelines that at the end, the only thing that changed is instead of having the code being in its original or source format, it's protected. So when we are transparent, when the Jscrambler process is transparent in regards to the development pipeline, we did a great job. But how do we do that? First, we have to make sure that our integrations into their build processes is seamless and works as intended. So we try to make sure that our integration works with every kind of build processes on different frameworks. Then we have the configuration tests, making sure that every kind of transformation or code technique or obfuscation technique we use and countermeasure works in the builds. Then we have the end product functional testing. We have to make sure that by using us, the product in its final state is functionally the same that when we're not using Jscrambler. So we try to host the protected code, make sure that the customer is able to do everything he was otherwise able on unprotected code. But this interface is subjected to external changes. The most deductive of you might have already figured it out, that due to the fact that this works in tandem with development frameworks, we are in a context in not all change is originated by us. Sometimes where there's a framework release, we might lose compatibility. The build process of a certain framework might be changed, major changes, and we might lose the ability of being seamless. So we have a solution for that. We have a testing system that works in two different stimuli. First, when there's a version of a framework that gets released. Imagine we get a notification that Angular is releasing a new version. First, we have a testing system that triggers a test for a specific framework project that we have. We have already pre-set up different projects, one for each of the different frameworks we have, and we trigger every single test I've said before. We try to build, we try to serve, and try to make sure that the project still works as intended. Then we return those tests, those results to the testing system. From there, we have to make sure that we were successful in every step. And if we're successful in every step, then we're able to say that we're still compatible with the new version of Angular. If not, if any of the tests failed, we have to make sure that we're still available. So that issue is tracked back to the developers. The developers do the according changes, and we release a new version of the plugin. But at the new version of the plugin, we also have to make sure that the changes we've done doesn't trigger any kind of regression within the other integrations. So we go through the whole pipeline again, but instead of just testing for Angular, we test for all the frameworks, making sure that the changes we did to accommodate for the new Angular version didn't break anything else. If everything goes seamless, again, we bump the version back and we're officially compliant with the new version of Angular. But now we have the tests for the protected code. We test to make sure that the quality of the protected code is up to standard. We strive for polymorphic transformations in which each single run generates unique code. There's ways to mitigate that or to undo that by using a same randomization seed, but we thrive on polymorphism. Then we have the browser compatibility. When the customer presents us with a source code, he has an intent of using that source code on their client base. Imagine he has segmented that this client base uses Internet Explorer 11. When we create protected code, we also have to make sure that the same browser compatibilities that the source code had are reflected in the protected code. Then we have the intent verifier. One of the last things we want to do is to protect malicious code that will in some way do either malicious actions or have a malicious intent, and to have the name of the Jscrambler attached to it. So we have two major verifiers. We have malicious code verifiers, in which we're trying to verify that we are not protecting any kind of web virus or malicious or bad ill-intended code. And the second is we are trying to verify whether we are not protecting any kind of bot, any kind of purchase bot, any kind of things that are currently creating the GPU shortage. We also have a different kind of, I would say, different challenge, which is antiviruses false positives. Due to the nature of our protections, sometimes we have the signature of a virus, either through the calling of a function or through the digital signature of a certain transformation we had. And we want to mitigate that. We want to make sure that if our protected code is flagged by an antivirus, we don't serve that code to a customer. Then we have the configuration testing. We try to test every single technique that we have, making sure that technique is still able to do its job and is still up to standard to what we want it to be able to do. Then we have code growth and obfuscation. Code growth is here to the fact that you saw that when we went from that Fibonacci function at the beginning into the protected code, we had a lot more code. Protection comes at a cost. And that cost, most of the time, is code growth. We don't want to be the reason why Webpack bundle went from 100Ks to a megabyte. So we have to take that into consideration and that into control. There's also the obfuscation time. We want to make sure that our techniques are being able to obfuscate that code in the correct manner, but also not taking too much time, that the time that a certain technique takes to obfuscate is still within our standards. Then we also have the combinatorial analysis, at least for the countermeasures, which is a way of testing if every single combination of countermeasures work as intended, if they don't countermeasure themselves. If I say that when a countermeasure, I want something to break when a countermeasure is activated, that the other countermeasures aren't broken by that fact. And then we have the end product obfuscation impact analysis. This is to mitigate the impact that we have on the functionality and the performance of our source code. When a client does or creates a website, they intend or they expect to have a certain kind of performance. And our goal is to minimize the impact that we have. Again, security comes at a cost, and we try to minimize that cost as much as possible and to keep it under control and to make sure that we know the cost at any single given time. Then we have double PI. As I remember, double PI is the whole antivirus on the web page thing. Okay. At the center, again, we have the Jscrambler stack. Then we have our agent, the agent that is currently running or is running on the web page under analysis. From there, we have the configuration of that engine. We have the engine behind our stack, all the configuration, which decides what is going to happen, what is happening, what do we decide gets blocked or not blocked or ignored. And behind that, we have the configuration behind it, the actual rules, the rules that the customer is able to create and to ascertain, okay, I don't want this script to run at this moment, or the only scripts I want to be ran in this page are first-party ones. So again, same principle. Let's go through all the interfaces and see the challenges we've been facing on. So the agent interface. The agent has to be always available. We can't promise to secure a web page from different attacks if agent is not being correctly loaded and always available. We also have browser compatibilities. We want to make sure that the presence of our agent does not break anything on the browser. A browser that can be used is a customer of our client not being able to use the client's interface. So we are actually preventing someone from using. We're not defending, we're blocking. We also have context testing. The presence of our agent alters and proxies and does small alterations to the browser context. And you have to make sure that those modifications, alterations, do not break the normal behavior of our customer's page. And then we have the browser impact. Again, the keyword of today is security comes at a cost. Our presence in the customer's page has an impact on performance, either through renderization time, loading time. We want to keep that at a minimum, and currently our minimum goal is 10%. Anything above 10%, and we have to verify and make sure that everything is working accordingly. Then we have the engine. We have the backend configuration. In the backend configuration, we do load and stress testing, making sure that the load and the usage that our customer is having on their website is being accommodated accordingly on our backends. We are not losing track of any events, and we're not losing track of any alerts that any session might have triggered. We have functional testing. We have no interest in having high availability if our product doesn't work. So we have to make sure that every single decision or event is being picked up correctly. Then we have recovery testing. We must have high availability. High availability means that when something goes down, we have to pick up the slack of something goes down. But from there, we also have three things to do. We have to mitigate the downing of a system. We have to recuperate the downing of the system, which is offloading all of the data, the hot data that might have been offloaded somewhere else. And then we have to recuperate, being able to restore the high availability to the maximum of its potential. Then we have the configuration, which is where the customer is able to configure our product to their needs. Again, we have functional testing, making sure that when a customer states that he only wants these scripts to run when he's on a certain domain, that those scripts only actually run when they're on that domain. Then we have, again, browser compatibility. We want to make sure that our product is able to do its function in any given browser, in any given operating system. It doesn't matter if it's Internet Explorer 11 or if it's the latest version of Safari. We must be able to function in any given context. We also have the rules testing. When I say that I want a script to only work when it's first party, I'm actually employing one or two rules. And every single rule has to be tested individually. And then we do combinatorial analysis between them. And finally, we have the combinatorial analysis of everything above. I want to make sure that a given rule works as in a certain way in a certain browser. So that leads to a lot of different use cases. So what have we learned from this journey until now? So testing everything has a cost. But one way we found to mitigate that is to test or to prioritize what has the highest impact. And what has the highest impact? For us, it's two things. It's what the customer will use most of the time. And second of all, what brings the biggest revenue. The second major point we want to have is don't focus on having tests. Tests are a building block for something else. I should rather focus on having a strong system and procedures for testing. If you have tests are valuable. tests will fail, either through external or internal changes. They will fail. Having strong system and procedure will make sure that that failure will be mitigated, and you'll still be able to do your two main objectives as a QA engineer. One, ascertain quality, and two, if that level of quality ever drops, you're the first one to know. And the last point I want to touch is the QA team does not own the quality. The whole engineering group does. So try to be dependable and try to have their backs. This was my talk. Thank you all for coming and hearing me. If you have any doubts or being interested in trying out Jscrambler, please find us at jscrambler.com. If you have any questions, if you have any comment, please reach me at just.santos@jscrambler.com. Thank you a lot.
Muito obrigado, Joss.
Nada.
Muito obrigado pela apresentação, bastante intuitiva e bastante clara e concisa. De momento aqui no chat não temos qualquer questão. De qualquer das maneiras, fica aqui também o seu contacto de e-mail e também o endereço do website da própria empresa, em que quem estiver a assistir e tiver depois alguma dúvida, entrar diretamente em contacto com o Joss e responderá, obviamente, oportunamente. De resto, Joss, não havendo, nós podemos concluir então a sessão, agradecendo uma vez mais por ter encerrado este dia em grande. E informar que, pronto, amanhã retomamos no terceiro dia do Cyber às 9h15. Muito obrigado, Joss. Obrigadíssimo. E continuação de boa semana e bom trabalho.
Obrigado igualmente.
Obrigado.
Adeus.